Hello friends, welcome back. In this lecture we are going to see what is DevOps, then DevOps engineer roles and the tools what do we cover in this training. First let's see what is DevOps. I'm going to show you the Wikipedia definition. DevOps is a set of practices that combines software development and IT operations. So it has set of practices which combines software development, nothing but dev, and IT operations, nothing but ops. So who is managing these two with the set of practices? Those guys we call it as a DevOps engineers. The aim of DevOps is to shorten the system development lifecycle and provide continuous delivery with high software quality. So you can understand continuous delivery in later point of time, but using this set of rules, we are going to deliver the high quality software. That is the simple definition of DevOps. Let's go and see what is the roles of DevOps engineers so that you can understand more clearly. So DevOps is quite simple and it is difficult. Why it is simple and why it is difficult, you are going to understand by end of this lecture. First, let's see what DevOps engineer does do. Developer give you a piece of code. To whom they will give? They will give it to the DevOps engineers, and the DevOps engineers has to copy this code onto the server. So he has to copy this code onto the server. But while developer giving this code to DevOps engineer, he asked us to follow some rules or he kept some conditions. Let's see those conditions or rules. If we see first condition, I will give code every day or couple of times in a day. Okay, if developer is giving code only once, it could be easy for us to deploy on a server because only once I can copy this one onto the server. But if he is giving multiple times in a day or every day, somehow I need to manage this code, and also I should have proper tracking when he has given that code to me and also when I have deployed that onto server. For that we may need additional tools. Next condition is compile and deploy it on test and prod servers. So before taking or copying this code onto the server, we need to compile it. So we need to deploy it on test servers. So it is not only one server. There are different environments, test environment and prod environment. So he is asking us to do a compilation and also deploy it on a test environment first to test it, then onto production servers. So it means we need to compile this code every time, every day, and also we need to deploy this code every time and every day on test environments as well as on production environments. So if it is once, again, it could be easy, but if it is multiple times, maybe I need to think about some automation or using some tools. Next, prod servers are used by client, so it should be up and running all the time. This is one of the biggest problem. So if I am deploying this code, that code may or may not work on production systems. So if it is not working, it is difficult for our clients. I should take care that only working code I should deploy over here because clients are using, and it should be up and running all the time. To achieve these three conditions, we need to do some activities or some automation before copying developer code onto the server. Let's understand with the diagram. If you see here, developer has a code on his system. Now I want to copy this one onto the server. But he said he is going to give this code every time. So I need to maintain his code appropriately. To maintain this code appropriately, either we can do some automation or else we can use a tool. So there is a tool called source code management tool which helps us to manage our code appropriately. So we should use a source code management tool. We are going to see what are the products of source code management in later sessions, but we should have a source code management which can manage our source code. Next, we are having this code, but we need to compile, right? This code every time we need to compile because code cannot be directly understood by your server. Your server can understand only system understandable language. To convert this source code into a system understandable language, we need to compile it. So we need compilation tool to compile our code. Once it is compiled, we need to do testing also, right? So to manage this compilation and testing appropriately, we need a integration tool. So we should have a integration tool. So if it is working fine, I want to deploy it on a server. If I am deploying only once, that would be fine. But if I am deploying multiple times, I need some automation tool. That is where deployment tools comes into the picture. So we need a deployment tool. So I'm just giving a what tools do we need, but these tools have the products. Deployment tool have multiple products. Integration tools might have multiple products. We need to choose at least one product in these categories. Okay, so once it is deployed on a server, in case servers are not working or not functioning properly, to manage these servers, we need IT infrastructure. So IT infrastructure nothing but multiple servers. In case server is not running with after deployment, we need a new server or some additional resources we need. All this come under to infrastructure. Okay, next our code is deployed on a server. If it is up and running, we need to monitor our applications or our servers. Why? Because whether it is working fine or not. For that we need monitoring tools. So we should use monitoring tools to manage these servers properly so that we can make sure that these servers are up and running all the time. If you see, these are the minimum different tools we should use to deploy developer code onto a server appropriately. Okay, now we'll see how the complete software development lifecycle works. Then you can understand where exactly we are going to use this. Here you can see different stages of software development lifecycle. Let me explain how does it work. Usually client come up with a requirement, nothing but a project. That project is analyzed and prepare a documentation by the project management team. These guys prepare a documentation that what exactly client is looking and what could be the final application. This application goes to the development team. So development team understand those requirements and start building the application to fulfill the client requirement. While they are developing, the code will be pushed into the source code repository. Source code repository nothing but where they keep their code. From the source code repository, it will go to the compile stage because source code cannot be deployed directly onto the server. That's the reason. First, it will go to the compilation. Once it is compiled, then it undergo with a unit test. Unit test nothing but whether this code is functioning properly or not. That can be done at the unit test level. Then static analysis. Static analysis nothing but whether we are following the code standards or not. In case some vulnerabilities or security alerts are there, it can be analyzed in the static analysis. Once it is fine, then it goes to the packaging. From packaging, it goes to the environment provisioning. Nothing but to deploy this package, we need servers, right? Those servers are containers or VMs. Here we are going to provision those systems. Then system of records, nothing but if this application may require some inputs from the other applications, those are virtualized, but we can concentrate here very less. Why? Because it will come in the initial stage of your software development life cycle. Then acceptance test, nothing but whether product is working fine or not. Then deployable software is created. Deployable software means it can be given to the client or anyone. We can deploy it and we can test the application. So here we do unit testing. Here we are going to do the functional testing. Unit testing nothing but we do on the source code. Functional testing we do on the deployable software. So here we do load testing, nothing but what are the resources requirement to run this application, how much CPU RAM is required. Then performance testing, how it is performing after running couple of hours, is it consuming more resources, is there unnecessary resources is it holding. These kind of things done at the testing phase. Ready to release software, once it is undergone with these requirements, if everything looks fine, it is ready to release the software. Then production environment, it will go to the production environment, means production servers with the appropriate approval from the clients. Once it is running on production and everything is fine, client confirms that this product is working as expected. But if we need additional features, again it will go here and this cycle will be continue until this product reaches to the customer expectation. But if you see in the real world, most of the products are continue to enhance because they have to release new features quite frequently to attract the customers. So this entire flow would be continue to work as long as we are releasing new features. Okay. Now let's see a little bit of animation. How does it work? I'm going to quickly explain with animation. First requirements goes to the software development team and they build the code and push it into the source code repository. Once it is there in the source code repository, it will go to the compilation stage. Here code get compiled and then unit test runs on the code and unit test reports are sent to the project management team. Then static code analysis and it will go under to packaging. From packaging it goes to the environment provisioning. Here required infrastructure has been provisioned. Then it go under to system of records and service virtualization. Then acceptance test. Once it pass acceptance test, it goes to the deployable software. It becomes a deployable software. Then load testing. Then performance testing. Once it is done, it will go under as a ready to release software. So once ready to release software, it will go to the customer sign off. If customer agrees, it will go and deploy into the production. This is how the flow will happen. Here, if you see the tools involved at each stage, in the development and configuration stage, we have a Visual Studio and Eclipse which are used by developers. But actual DevOps engineer work starts from here. So source code repository has to managed by DevOps engineers. Here we can use Bitbucket, Git or GitLab. Here we have a Jenkins, that is continuous integration tool. On Jenkins we have compilation tool called Maven for Java. If it is a .NET, we are going to use MS Build. And unit testing we have Selenium, Proctator, JUnit, and static code analysis we have SonarQube. Packaging we have Nexus and Artifactory, and environment provisioning Chef, Ansible, OpenStack, Kubernetes, Vagrant, Puppet, Docker. All these are environment provisioning tools. Then service virtualization CA and Lisa. Acceptance test again Selenium, Proctator. Then identity and access management, these two tools. Application performance monitoring, these tools. Performance load testing JMeter. Ready to release software Selenium. These all are come under to testing phase, so we don't deal testing phase much in the DevOps flow. It will be tested on the deployable software. So here whatever happens, this we call it as a functional testing. Testing team involves in the functional testing. Then production environment, here AWS, Kubernetes, Docker, VMware. So these all are the tools we can use. And service management and monitoring, where we can monitor, here we have Logslash, Prometheus, Splunk. These all are tools which can be useful at the service management and monitoring. So if you see, I kept only few tools which are relevant under particular section. Apart from this, there are lot of tools are available, but we need to learn one tool at each category. Now I am going to show you which tools we are going to learn under each category. Before looking at the tools, first let's see what are the steps in the DevOps lifecycle. In DevOps, there is continuous development, continuous integration, continuous deployment, continuous testing, and continuous monitoring. These are the 5 steps which are involved in the DevOps lifecycle. Now we'll see what tools do we cover in this lifecycle. First one, continuous development. Developers use various tools to develop their code. Developed code get pushed onto source code management. So developers develop their code, then they pushed it onto source code management. To develop their code, they may use IDE. IDE nothing but where they write their code. There are a lot of IDEs are available. Among them, Visual Studio and Eclipse are most used one. Most of the cases, DevOps engineers doesn't write application code because writing application code is not DevOps engineer role. DevOps engineers are responsible to maintain code using source code management tool. So we are not writing code, we are maintaining the code. So to maintain code, we need to use source code management tools. I have shown you that, right? We need to use source code management tools to maintain their code. So under continuous development, we don't develop the code, but source code management comes under to DevOps engineer role. This we are going to handle. If we see the source code management tools which are there in the market, these are the source code management tools: Git, Bitbucket, Subversion, Perforce, GitLab, and few other are there. These are some of the popular source code management tools. Among these, we are going to use Git as our source code management tool. With that, if we see under continuous development, we only handle source code management, that is Git we need to learn under continuous development. Next, continuous integration. In continuous integration, we have multiple tools again. We have Jenkins, Bamboo, Circle CI, TeamCity, and few other. Among these, we are going to use Jenkins as our continuous integration tool. So if we see in continuous integration, we use Jenkins. But it is a continuous integration tool. Here we are going to integrate multiple tools. If we see what and all tools we are going to integrate with the continuous integration, that is unit testing tools like JUnit, NUnit. These all are plugins. You can understand plugins later point of time. Next, code build, Maven, Ant, Gradle, code analysis, Vera Code, SonarQube, code artifacts nothing but once code is compiled, some output comes. That output we call it as a artifacts. To store those artifacts, we use code artifacts. Those are Nexus and Artifactory. We don't store artifacts on source code management tool, nothing but Git or Bitbucket. On this we don't store. We need to use artifact repositories for those. You are going to understand more details about this in the later sessions. So if we see for code analysis, we are going to use SonarQube, code build Maven, and artifact repository JFrog Artifactory. These tools we are covering in this course. So under continuous integration, apart from Jenkins, we are going to see unit test as JUnit, build tool Maven, code analysis SonarQube, build artifacts. We are going to use JFrog Artifactory as well as Docker Hub because we are dealing with containers. For that we need Docker Hub. Then continuous deployment. Under continuous deployment, we have various tools. We can use Ansible, Urban Code Deploy, Jenkins, Travel CI, Octopus Deploy. These are some of the tools. Among these, we are going to use Ansible. So, continuous deployment, we are going to use Ansible. Under continuous deployment, infrastructure also comes. Why? Because we need infrastructure to deploy our applications. So, infrastructure can be Docker, Kubernetes, or else traditional data center, Amazon Web Services, Azure or GCP. Like that we have various tools. Among these, we are going to use Amazon Web Services and Kubernetes. But teaching Amazon Web Services is not scope of this training, but we are going to deploy on this one. Later point of time, we are going to use Docker and Kubernetes. So here infrastructure, we are going to use AWS, Docker and Kubernetes. Under continuous deployment, apart from infrastructure, we also need to maintain configuration management tools. Configuration management tools helps us to provision these resources or maintain these appropriately. So if we see the configuration management tools, Ansible, Chef, SaltStack, Puppet, these are the tools which are there under configuration management tools. Among these, again we are using Ansible. Then continuous testing. Here most of the cases testing is done by separate team. So even though it is part of DevOps flow, we don't maintain the testing because again it is huge. So if we see the continuous testing, Selenium, Apache JMeter, Tricense, so these are the continuous testing tools. So we are not dealing with this continuous testing tools. So we can skip it. Then continuous monitoring. Under monitoring, we have Nagios, Jabex, Prometheus. Among these, we are going to choose Prometheus. So under continuous monitoring, we are going to deal with the Prometheus. So these are the tools we are going to cover in our training. So source code management, Git, continuous integration, Jenkins, unit test, JUnit, build tool, Maven, code analysis, SonarQube, build artifacts, JFrog Artifactory and Docker Hub, continuous deployment, Ansible, infrastructure. We are going to deal with AWS, Docker and Kubernetes, but in AWS we just deal with EC2 service. Apart from that, nothing. Configuration management, Ansible, then continuous testing, we don't deal with anything, then continuous monitoring, Prometheus. These are the list of the tools. Don't get scared by looking at these tools. These all are quite easy to learn. I'm going to show you with examples so you can able to correlate with the real-time work so that you don't feel like you are learning a new tool. It will be like a process. At last, if we see our first diagram, this is what we have seen, right? Development system and server. Next, it involves these steps. We need a source code management tool, compilation tool, integration tool, deployment tool, infrastructure, and monitoring. Here, source code management, Git, compilation tool, Maven, integration tool, Jenkins, deployment tool, Ansible, infrastructure, AWS, Docker, and Kubernetes. I just kept Kubernetes. Then monitoring, Prometheus. This is how we can choose tools. And I have chosen these tools depends upon the market share because most of the industries are using these tools. That's why I have chosen. So it will add benefit for you if you learn these tools. Alright, that's all for this lecture. From next video we are going to see our source code management tool called Git. Thanks for watching and see you there.